So, welcome to this tutorial of multi-attribute theory. It is also known as MAUT. MAUT. So, it is the concept is developed based on utility function. So, which is equals to U. U is the utility function, and it states that suppose you have a coin and this coin has naturally one side is head, another side is tail. And it says that if head is there, you will get $10. If tail is there, you will get minus $10. And if nothing happens, means you do not flip the coin, this is also there. This option is also there. We say it as don't flip coin. So for that, you will straight away get $6. So by comparing each of these options, we find that this is most rewarding, followed by this one. But this is not rewarding, but loss-making option. But if we flip the coin, there is a chance that 50% chances that head will come, 50% chance was tail will come. So there is 0.5 or make it 50% probability that $10 can be deducted from it. So that is the risk. So if you decided to flip the coin, then you are taking the risk. Okay? But if you decide not to flip the coin, then you are not taking any risk. However, you are getting $6. So, there are three types of person. One person will take the risk, which are also known as risk seeker. One person, another type of person will try to avert the risk, and another type of person will be neutral, risk neutral. So risk seeker is this person which decides to take the risk, to flip the coin. So there is a 50% chance that you will make profit, and 50% chance you will not make. Instead you will make loss. So this type of person is risk seeker, and the person who is a risk aversion type, he will decide that he will not flip the coin and will be satisfied with the $6 that he is getting. And what about the risk neutral? This risk neutral person is third type of person will neither take risk nor try to averse the risk, but will remain in a neutral position. So, what type of position is that? It's very interesting to know. So, if I say that there is a coin, so in the first chance, when you flip it for the first time, this is the risk. But if you flip it for the second time, so there will be no risk. No, that means $0 will be awarded if head comes, and $0 will be awarded if tail comes. So no difference in that. So this thing is a risk neutral. There is no risk. So and there is nothing to avert. Okay. There is no need of averting the risk, no need to taking the risk, remain in a neutral. Now it is said that when you are a risk taker, your utility function becomes u is equal to x squared. This is the independent variable, and utility function is the dependent variable. So when you are taking risk, your profit, if this is a profit function, it is squared. So yes, it is correct that when you are taking a risk, your profit will be squared. But as this is a risk, then actually this x will become 0.5 x squared. That means 50% chance of getting the profit, get $10. And there is also a minus 0.5 x squared. That means there is also a chance that your profit will be diminished. So actually then your utility or your profit is at zero. So utility of this risk taking will be zero. Because there is a 50% chance that you will get a profit, there is a 50% chance that you will suffer a loss. And the amount of profit and loss is same. So that is why here the result will become 0. That's x is equals to $10. So at the, in case of risk aversion, the same utility function becomes u of root x. That means you are averting the risk. Basically, this is the root x curve and this is the x square curve. Okay, so you are risk taking. So whatever you do, you get $6. That is confirmed. Okay. And what about the? Sorry, it is not $6. So if you are deciding not to flip the coin, you will get $6. But actually, what you are getting is u is equal to root over 6. So you see, this is it will come around 6 point or 7.04 like this. So let us do it. U is root over 6. So let us calculate that 6, then root over. So root 6, 2.449. So you can say that this is 2.4494 means 2.4. Okay, actual bound is $6, but as you are not taking risk, the utility function of this is 2.44. Because they are considering that as you have not taken the risk, you are avoiding the risk. That is where we have also missed earning the $8. So that is also your loss. That will count on your loss. If you would have taken the risk, then you could have got $10. But you are now take the risk, so you miss the chance of getting $10. So you have to be satisfied with $6. That is why in this case utility function is 2.4. Now when you are risk neutral, so this is the risk neutral case. Second term, you will get $0, either you get 8 or 10. So your utility function becomes $0. Right? So it can also say as u is equal to x. So in summary, what we can say is that when there is a risk-taking scenario, it will become u is equal to x squared plus profit or loss, both will be multiplied parabolically. Risk-seeking option, u will be root over x if you are averting that risk. Okay, so you are missing the chance of profit here by averting the risk. And when you are risk neutral stage, you are straight away getting you are what the only option is there. That means $0. So you get. So you see, there are three different options with three utility functions that can be used in decision making. And in case of multi-attribute utility theory, the procedure is like this. Suppose you have an industry, so, or you want to go to a shop and you want to purchase a car, and you have been provided three options. One is Maruti, one is Toyota, and another one is Wagoner. And you have two criteria. There can be multiple criteria, but we are using here two criteria only. Profit or sorry, not profit. Let it be price, and another one can be reliability. So this function price is a numerical function, quantitative function. This function is a qualitative function. But let us represent this reliability in terms of percentage. More the percentage, more reliability. So based on the price and reliability percentage, you can rank these three options. Let it mean this is Maruti, this is Toyota, and this is Wagoner. So in case of price, I think Maruti has the lowest price, and a purchaser will always go for the lowest price. So this option becomes top option, followed by Wagoner, and lastly Toyota. The starter is the most expensive among these three. However, in case of reliability, it's Toyota has the highest reliability, followed by Wagoner and Maruti. This decision can be very controversial, because some will say that Wagoner has lesser reliability, some will say Wagoner has better reliability. It will depend upon the decision maker. But overall, this is the rank you can assign to all these options. Now, your first step will be find the inverse rank of the rank of all the alternatives, okay, for each criteria. That means these are the rank of all the alternatives, these are the alternatives, and these are the criteria. So they're saying that for each of the criteria, whatever rank you have assigned to all the options, the alternatives, you calculate the inverse rank. How you calculate the inverse rank? You see, the formula stands like this: 1 minus n by n plus 1. So this n is the total number of alternatives. This n is the rank or position assigned to that alternative, and you can deduct this ratio from 1 to get the inverse rank. So let us practice with the first one. First one as Maruti has the rank 1 in case of price. So m is 1, n number of alternatives here 3. So you will write 1 by 3 plus 1. That will be 1 by 4, which is equal to 0.25. Now 1 minus 0.25 is the inverse rank value. So actually it is 0.7. Basically what happens if you compare all these three alternatives based on the rank, then it is okay. 1, 3, 2 is okay, perfectly okay. But if you consider this rank as the magnitude of this alternative, that means let us say, if you say that Maruti has a price of 1, Toyota has a price of 3, and WagonR has a price of 2, uh, then it is a little difficult to represent exactly what this data is showing. So let us take the reliability. If you say that Maruti has the 3 reliability, Toyota has the 1 reliability, and WagonR has the 2 reliability. If you consider this as the rank, then it is okay. But if you consider this as a magnitude of reliability, then it is not. So that is why what we are converting is, we are converting the rank into its corresponding magnitude. So this one will be 0.75. This 3 will be actually 1 minus 3 by 4. So it will be, what is 3 by 4 if you calculate. So this is 3 divided by 4. This is 0.75. You see, so 3 by 4 is 0.75. We are deducting this 0.75 from 1, it is becoming 0.25. So this will become 0.25, and 2 naturally this will be 0.0, because 1 minus 2 by 4 is actually 1 minus half, and half is 0.5. So 1 minus 0.5 is 0. Okay. Similarly, this would be 0.25, this will be 0.75, and this will be 0.5. Now, you see, this is the profit loss thing, and one thing you will notice that more the price, lesser is the preference. More the reliability, higher is the preference of selecting that option. So in that case, you see, this rank itself is representing that the cost of Maruti is more. So remember that if you use the magnitude of price for Maruti, Toyota, and WagonR, then uh, then what will happen is magnitudically uh, this Toyota will be more preferred, because Toyota costs around 20 to 21 lakhs. Maruti cost around 3 lakhs, and WagonR is 8 lakhs. So if you compare this magnitude only, then it will seem that for price also the preferred decision is Toyota, as the magnitude of cost is much higher than Maruti and Moth. So that is why, to remove this constraint, we use the rank. Once you use the rank, you know the value of the options for that criteria becomes dimensionless. Okay, dimensionless. So it becomes more flexible, and you can do any operation on those dimensionless terms. You can avoid the impacts caused due to the difference in units, because you see this price is actually in terms of rupee, dollar, or any currency, and reliability is in terms of percentage. So both these units are different. So you cannot do operation with the values of this criteria. You cannot just multiply the price of Toyota, that is 20 to 21 lakhs, with the reliability percentage of Toyota. So that will not, that you cannot do mathematically, you can, because both are from different units. That is why. So that is why we have used this rank concept instead of map. So now the second step of multi-attribute utility theory, let us say it is the second step of multi-attribute utility theory. So let me clear my board. So the second step is you have three values for price and three values for reliability. And you have converted them, you have used the ranks, and you have converted them into its inverse value. So in case of price and reliability, 0.25, 0.75 and 0.5. And here also I think it will be 0.7, 0.25, 0.75, in case of reliability, 0.25, 0.75, 0.5. So this is an example. So why I am saying that is that so so in case of price it is 0.75, 0.25, 0.50, 0.75, 0.25 and then 0.5. And for reliability it is 0.25, 0.75 and 0.5. Okay. Now what we have to do is the second step. So there are three options available. One is risk aversion option. One is risk seeking option. And one is risk neutral. If you use this risk aversion option, what you will do is you just square root all the values. And you just square root all the values, these values as well. And then this is very interesting thing. So without square root, if I add all these three values, it is coming as 1.5. Here also it is coming as 1.5. Now after square rooting, because our main aim is to find the most significant decision or most significant alternative from the Maruti, Toyota and Wagoner. So what we will do is, this is very interesting thing. Let's look at that. We just add these two values, these two values and these two values. And after adding, means we first square root it, then add it. So Pm plus Ra, this is also Pt plus Rd. The price, the value in price plus the value in reliability is added for Maruti option, Toyota option, and also Wagoner. So you see, when you are square rooting, you are risk averting. So what we'll do is, straight away you will see which among these three has the highest value. Which among these three, so this is A, this is B, and this is C, then compare A, B, and C and try to find the maximum. So, if A is maximum, MAUT is the preferred choice. If B is maximum, Toyota is preferred choice, and if C is maximum, W is your preferred choice. But it doesn't stop here. So this was second step, substep 1. And in substep 2, what we do is, we will use the utility function of risk seeking. That means U is going to x squared. So these will be squared, squared, and added. Squared, squared, and added. Squared, squared, and added. And there also the new values of A, B, and C will arise. So A, B, C for risk aversion and A, B, C of risk seeking is there. No need to calculate the utility function for risk because this U is going to X. So from this value of risk aversion and risk seeking, after this, what we do is from risk seeking we minus risk aversion. So for risk seeking, if A is the value, then A risk seeking will be minus from A risk aversion. Because this risk aversion, here you are avoiding the risk, and here you are taking the risk. Okay. So basically, sorry, yes, one thing is mistake here. You will, okay, no problem is there. Yes, I was correct. You will deduct risk aversion from risk seeking. Risk seeking minus risk aversion. Risk seeking. So if you do this, it is known as positive utility. And if you say no, I will not do that, I will do the opposite. That means you will deduct RS from RA. Okay, then this will become negative. Why so? Because risk seeking has a greater potential of profit, greater potential of utility, and aversion has a lower potential of utility. So if you deduct the high from low, then only the maximum values can be generated. Okay, and once you generated this RS minus RA for Maruti, RS minus RA for Toyota, RS minus RA for Wagoner, you compare these values with each other. And in case of positive utility, more the magnitude of the difference, more preferred will be that option. So if Maruti, or sorry, in this case we can come first. You will see if Maruti has come first. Okay. So if Maruti has come first, then the risk for RS minus RA, if the value of RS minus RA for Maruti is highest compared to Toyota and Wagoner, then Maruti will be the preferred solution. Okay. Now there is another step to this MAUT method, but this is an optional step. It is not compulsory. You can avoid this step, or you can implement this step. If you implement this step, it is beneficial. The decision will be more pronounced. If you do not implement this step, then only also you can make it. So in the second step, or second way, what you will do, if you know what is the weightage of significance for profit and price and reliability for your decision to purchase a car among the alternatives Maruti, Toyota and Moth, then what happens when you are adding, when you are adding these two values, what you can do is, at the time of adding, you can first multiply the weightage of the price with the value of the price, then add it with the product of weightage of reliability and the value of price, and then consider it as equal. Similarly, for row 2 to row 3, you can have this policy. The advantage is that decision at the end of the method will pick a alternative by considering the difference of significance between these two criteria. Maybe you are more preferred to inclined to reliability compared to price, then in that case the weightage of reliability will be higher, weightage of price will be lower. Okay? But if you straight away just add it, then this information will be, so sometimes it is seen that for overlooking the weightage of significance of the criteria, erroneous results are. So, okay, overall, this is what Moth is. Let me summarize. So here, what I have said is, first step is you rank the option as per the criteria. Here there was two criteria, three alternative options. So what we suggested is, first, uh, first try to find the rank with the help of the magnitude provided for these three alternatives, and then you inverse the rank with the help of the formula 1 minus m by n plus 1. It is very easy formula. M is the rank of the value data, n plus 1 is the total number of data set, and you will get the risk score. And after ranking and getting the inverse rank value, what I say as short IRP. So what we do is we try to find out what is U is equal to X squared. And whatever rank whatever rank you have assigned to A1, it will be squared. It will be multiplied with the weightage of C1. So multiplied, and here also it is W2 into A2 squared. And what I have said is you have to add them. So to get risk seeking value for A1, similarly we will do that for A2 and then A2. So for each of the option you will get 3 RS. RS means risk seeking value. Similarly, when you multiply the weightage with the square root of A1, multiply the weightage with the square root of A2, and multiply the weightage for square root of A3. So this is what we will say. The first case, risk taking. Sorry, first case is risk aversion. What I have shown. You will have to square root each of the value and add them. For the risk seeking, you have to square the value want to square the some what I would say some way. So what will happen is here they are calculating risk seeking, and then they will deduct the risk aversion thing. So that is okay. So this is what is this interest bank formula is called. Okay. So overall this is the step of MAUT, MAUT. So what we do, let us again summarize, because first step rank etc. to each of the alternative. Second step is calculate the inverse rank value. Third is what? Third, I can say that after finding the IRV, you square it for each of the option and its values of the relativity. And then what you do after squaring the IRV, then first one, then you have to do this next thing for IR square, because both of them are squared. And why this is squared? This is where you utilize the derivative function using the square, which is generally used for alerting the participant of some group sure of something and avoid overdoing or overtaking time frame. So U squared will be the risk seeking, U root over x will be the some else, and not someone else, it is U is equal to x squared, U is equal to root x, and for the risk function it is U is equal to x, so we have nothing to calculate for this. But for U is equal to x squared and U is equal to root over x, what you have to do is you have to deduct the root over x thing from the x squared. Okay. So after then some value will come, which is actually known as risk function or utility function, whatever you want to say. And by comparing this risk function for each of the alternative with each other, the alternative with the highest rank function or R will be the preferred city.